Let's talk about how we can connect to Minecraft using WebSockets. So it turns out that Minecraft has an option to connect to a web server when we are in a game, and specifically WebSocket server. And the socket server can send and receive any commands. So the way commands work is in Minecraft, when you type slash, you can type in something like, let's say, set block, which changes the block from one to the other. So I can say, well, just maybe one step away from me, or well, let's look at tilde 1 0 0. So that's basically just one step away from me towards X. And I can set in any type of blocks. So what we'll do is maybe create a grass block. That's just grass. And I can put in more information about that type of grass block. But for now, I'm just going to leave it blank and press enter. So what that's done is placed a block. Okay, I have no idea where it's placed it. Oh, right, I gave the command wrong. What I should have done was set tilde 0 because that means it's relative to me. Otherwise, it's placing it at an absolute y and z of 0. So that, yes, placed a grass block right next to me. So this kind of command can be sent from a Minecraft WebSocket server, sorry, from a WebSocket server to Minecraft and vice versa. Let's talk about how we do this. I'm going to use Node to run this. So I've already installed Node.js, which you can from, well, you can just go to nodejs.org and select any of the download options that are available here. Now let's create an application that acts as a WebSocket server. For this, we need a WebSocket module. I'm going to use the library that comes with npm, the node package manager, called WS. This seems to be a fairly popular WebSocket library, and the way it works is you can require WS and create a new WebSocket server with a bunch of parameters. And yeah, that's pretty much it really. So let's install it, npm install WS, and that will allow me to require the WS package. So copy paste this code, const WebSocket is require WS. I don't use semicolons, I just get rid of that. And then, well, we'll create the new WebSocket server. The only real thing that it requires is what port we run it on. I'm going to run it on port 3000. No reason. It could be literally any port. And then after that, we have to start the server. Well, actually, this would pretty much initiate the server, but we have to tell the server what to do when it gets a connection or when it gets a message and so on. So the way to do that is using the connect event. So when it gets a connection from Minecraft, we can run a function that does whatever we want it to do. For now, I'm just going to, let's say, uh, console.log of connected. So now with this code, when I run mineserver.js, it's doing nothing, but presumably the server has started. It will be good to have a message that says server started. So let's say console.log ready, and on Minecraft, what we should do is type /connect local host colon 3000. That's basically giving ourselves instructions that what we need to do next is on Minecraft, type this as a command. Let's do that. We'll get back into the game and /connect localhost colon 3000. And you'll notice that it said connection established to server ws colon / localhost. And out here, it says connected. So which means that our WebSocket server is ready to send and receive messages. Now, this, in case you get a message saying cannot find module WS, that basically means you haven't typed npm install WS. That is what's needed to make the first line work. Now, if you want to disconnect, we can send /connect off, and that will turn off the message. Oh, yeah, the chat message says connection closed. Now we aren't printing anything on disconnect, so this on node there's just no extra message, but this connection has been disconnected, and we can demonstrate that by adding another connection. So if I reconnect, so now it says connection established, and out here it says connected again. Let's see what we can do next. Supposing the player types a chat message, we want to listen to it. Now the WebSocket server can now send a subscribe message to Minecraft saying that it wants to listen to specific actions. So for example, you can subscribe to a message called player message, and anytime the player sends a chat message, MindSocket will notify our WebSocket client. So here's how we'll do that. What we do is in this add a request saying socket or let's do socket socket.send. We want to send a message. Now messages are sent as JSON strings. So we'll take a JSON object and stringify it. The object should have the following information. It should have a header, and that's a dictionary, and it should have a body, that's also an object. This header should contain the following information. It should contain a version, which must always be 1, because we are using version 1 of the messaging protocol. And the request ID should be some unique ID. ID. It could be any unique ID. I'm just going to put in 000. But actually a good practice would be to automatically generate unique IDs. A good way of doing that would be using a package called UUID, which generates unique IDs. And this allows us to use, let's say, UUID v4 as a function that generates unique random IDs like this. So in fact, why don't we just go ahead and do that? npm install UUID, and with that I can const UUID is equal to require UUID, and then we can have this request ID to simply be UUID.v4. The third thing that we have to send as part of the header is the message type, which must be a command request because we are sending a command request. And the fourth thing is message purpose. Here we say we want to subscribe to a message. So what we've told Minecraft is that we are sending a new request in version 1 protocol, which is a command request saying I want to subscribe to something. What exactly do we want to subscribe to comes in here as event name, which becomes player message. So we want to subscribe to all player messages. Now every time the player types something in the chat window, our socket will receive it. Now how exactly do we receive it? We would say socket.on whenever we get any message. We'll call a function and we'll get this as a packet. So let's say some packet, which is really just a string, which we'll process, and well, let's say json.parse of packet that will convert the string back into an object. We'll store it as the message. And for now, let's just print the message, console.log of message. So what this does is it passes all the messages that it receives and just prints it. This says whenever the player sends a message, send it to me. Let's run this. We'll run node mindserver.js. It says connect to this WebSocket. So we'll connect to the WebSocket in Minecraft /connect, and it's established the connection. Great. And our web server also says connected, so we are good. Now let's send a message. We'll say hello. Now we get a huge message printed here that says let's start with the header. The message purpose is an event which has a request ID of 0 and version 1, and this has the message hello, which came in as a chat message, and a bunch of other things. It says, for example, I'm in biome type 1, which is a plains biome. I'm on build 1.16.201 on platform 7, which I presume is Bedrock, which is what I'm on. This is my client ID and a whole bunch of things, and that I'm on Windows 10. So this allows us now to listen to all of these messages. Now, these messages are in the Minecraft WebSocket protocol, which is actually undocumented. But it turns out that there are a few places on the internet where you can search for this and get some information. So this is largely about trial and error. Let's go a step further and we'll start actually adding blocks. What we'll do is, well, when the player sends a message saying, let's say, pyramid, so when we get a packet that where the player types a message, say pyramid 3 or pyramid 5, we'll draw a pyramid. So how do we do that? Well, we know that the message body will contain a message property, which is the text that we type. So let's do this. Well, and of course, we have to make sure that it's a player message that we actually got. So let's make sure that the something, yeah, an event name is player message. So if message body event name is player message, then what we can do is create a match to see if we actually got a message that begins with pyramid. So this will be, let's say, message body. Message body has properties, and under these properties we have a message. And let's see if this matches. Let's see, so, a regular expression that begins with pyramid, and we can make it case insensitive. Yeah, let's also say it's pyramid 2 to create a pyramid of size 2, or pyramid 5 to create a size of pyramid, create a pyramid of size 5. So let's say put in any number of numbers after that. Now if we get a match, so that's if match, what we do is, for now, console.log of drawing pyramid of size, and this will be the match of 1. Now let's see if this works. Let's restart the application. We'll connect to Minecraft again, and we'll say pyramid 23. So that says drawing a pyramid of size 23. Now let's actually draw the pyramid here. So what we'll do is, instead of console.log, we'll create a function, draw pyramid, and we will send this. Well, since it's a number, we may as well just convert it to a number. And now what the pyramid function should do is, well, actually draw the pyramid. Let's do that. We'll create that function just maybe below here. Draw pyramid is a function. So yeah, let's just declare it as a function which takes a size object. Yeah, typo there. And this should, let's see, what we'll do is loop through. So if it's size, then let's start from bottom to top. We'll build the pyramid from the bottom. So let's say the y coordinate starts at 0 and goes up to size and keeps on incrementing. So that will be the y coordinate. Now at y is equal to 0, we want to draw a rectangle of whose side is, well, the full size. At y is equal to 1, we want it to be size minus 1, y is equal to 2, it will be size minus 2, and so on. So the side is basically the size overall of the pyramid minus y where we are. Now let's actually draw the rectangle. For let's say x, we start with minus side, and x less than or equal to side. Keep incrementing x, and we'll place 4 blocks, left, right, front and back. Now for this, what we'll need to do is actually send a set of commands. So how does one go about sending commands to Minecraft? Well, it's actually using a JSON protocol again. So what we'll do is first create a function called send, which takes a command. And we'll want to send commands like, well, we'll say send, we'll want to send a set block command of some kind. So let's say, let's create a set block, some number. We'll have to figure out the number. It will be, let's say, X. I'll convert this to an F string, sorry, a formatted, a template literal, $Y, something like that. And then maybe we'll place a glowstone block. We'll also need a $Z. So once we create a command like this and we want to send it, the way the command should be sent is we'll create a message first, which is an object, and we'll finally send it as a JSON stringified message. This also requires a header and a body. And the header should contain a version, which is 1, a request ID, which should be uuid.v4, some unique UUID, a message purpose, which in our case is going to be again a command request, and it should contain a message type, which again is a command request. The body should contain a, actually I don't know if it needs a version. Actually, I don't think we need a version here. A command line, which says that this is the command that we want to send. And we can put in an additional information saying where this command comes from is type player. I'm not really sure if this is required. I just am using this from one of the sources that I found on the internet. Once we have this object, this message, we can do a socket.send. Socket is still defined. We're still in the same inner function. So socket.send of JSON.stringify of message. And that should be able to send any command that we want. Now, let's actually send the block positions. What we want is to send something just in front around us with a distance of X and a distance of Y, which is the height. And the Z, in this case, let's say minus side, that should cover one part of the rectangle. Then let's put in plus side, that should cover the other half of the rectangle. So that's basically saying we're keeping X constant as the side. Then let's send one where we keep X constant as a side at minus side and put it at X and plus side and put it again at X. So that should set 4 glowstone blocks and sort of build a rectangle around the constant Y. And as the Y keep increases, it will keep building one on top of the other. So let's try our luck. We'll stop this server. We'll run Minecraft again, connect to it. That's connected. And we'll say pyramid, let's say 3. Pyramid 3. And that closed the connection because drop period is not defined. Well, obviously, I should make sure that I have an M here. Let's try this again. We connect to localhost, and that's connected. Let's try saying pyramid 3, and it didn't do a single thing. We should have been surrounded by a glowstone pyramid. Let's explore what happened. Let's look at what commands we are running. Let's do a console.log to see what commands we're actually sending and see if we made a mistake there. Resume the game, connect again to the localhost and send pyramid 3. So we're sending, okay, a bunch of set blocks. So we are sending, oh, okay. So we are sending the X and the Y relative to us, but we forgot to send the Z relative to us. That's a typo. Let's fix that with a tilde here as well and here. So with that, the commands that we send should be better. Let's reconnect and let's create a pyramid of size 3. And oh, okay, that has created a glowstone pyramid around us of size 3. Let's get stuck in it. Let's break out of it and explore what it looks like. So as you can see, it started with y is equal to 0, then 1, then 2, and then went on right to the top, which is the glowstone we broke, and then created the rectangles around it. So which is cool. What's also cool is that I get to break this glowstone pyramid, which is always fun. Let's break it. What's not fun is that I fill the grass at the bottom, but in Minecraft everything's fun. So let's fill the grass. Of course, I could use a command to do this, but personally, I find it more satisfying to do this manually. Right, so now we've created a pyramid, and that basically means we can, well, do anything. Let's create a bigger pyramid. Let's create pyramid 5 and see what that does. Wow, we have a pyramid of size 5. Let's break out of this and go somewhere else and build an even larger pyramid. Well, let's build a pyramid in midair. So pyramid 10. Not quite. Pyramid 1, 0. And that, let's see the whole pyramid now. So you can see that it's actually created a huge, massive pyramid out here. Well, that was a very quick introduction into how you can use Minecraft to send messages. Let me do one thing. I'm going to remove this console.log, restart the server, and see if I can show you one other thing. Let's reconnect the server. And now we're again going to build a pyramid of size 10. Now you'll notice something. When I removed the console.log, it didn't really it didn't put the whole pyramid out here. The reason is that Minecraft isn't as fast as Node, and it only accepts 100 messages at a time. When we were doing the console.log, Minecraft, the WebSocket server slowed down a bit and printed each command and gave MineSocket enough breathing space to actually process the commands. But what happened now is that once it sent 100 of these, it got overloaded and choked, and Minecraft was actually sending back responses saying, I can't execute this command, I can't execute this command, and so on. Now, we need to handle that. So why don't we now listen to more of Minecraft's responses and see what they have to say. What we'll do is every time Minecraft sends a message, we'll log it. Specifically, we'll log it if it sends something called a command response. See, we are already listening to the messages, and we're saying if it's a player message, then do this stuff. But what we do is if the message header, message purpose, this is a command response in response to a command request, then let's do a console.log of that message. Now with this, let's restart and reconnect and create this pyramid again. Now, that didn't send anything, maybe because it did draw the stuff, but it should have sent a set of messages. Let's look at our text again. If the message purpose is command, oh, I got a typo here. It's command response. Now this should work. Let's restart our server and connect to it again and draw a pyramid of size 10. Now, yes, that put in a bunch of messages. Some of those say this block couldn't be placed. And I'll see if there's any other type of message. Command response, this block couldn't be placed. Let's go all the way up. Okay, here we got a block placed, block placed, block placed. So it managed to place a bunch of blocks. And then after a point, the block couldn't be placed. Now, the reason this happens is, well, because it got overloaded. And you can also get a different kind of a message that says too many commands have been requested and wait for one to be done. So here's what we are going to do. If there are more than 100 messages, we are going to put it into a queue and yeah, just send at most 100 at a time. So how exactly are we going to do that? Well, let's get rid of this command response. We'll create a couple of constants. Let's say one is a send queue, which is an empty list. This is what we're going to send commands into, and an awaited queue, which is where we'll be putting in the responses, meaning anything that we are going to send, we put into send queue. Anything we've sent but are awaiting a response, we'll put in into the awaited queue. Now, out here, well, let's check what messages we get. If the message header message purpose is the same, command response. Now notice that we get a command response that says for this particular request ID, I'm sending a command response, and I either couldn't place it, in which case the status code is negative, or I actually could place it, in which case the status code is 0. So we can use that to figure out if it actually managed to place the block or not. And we just wait until some of the blocks have been placed. So what we'll do is check if message header request ID. That's something that's already in our awaited queue. If it is, then if the message body status code is less than 0, which basically means if it's an error, then we'll print the error message, console.log. Now what does the error message look like? Command response, all of these are block placed. Yeah, so body status message. So we'll do a, well, let's also print the command that should have been sent. We'll get that from the awaited queue. The awaited queue will have based on the request ID. So message header request ID. That's where we'll put it. And then from there, we'll take its body command line. Basically, all of the messages have a body, no, here. Yeah, a body command line, which has the actual command. So we'll know that this particular command has not been executed. And we'll also print the exact error that we get. Message body, sorry, not quite, message body status code. Status code. So that will print the error message. But in any case, now that we've got a response, either it was successful or not, we can delete from the awaited queue this particular message header request ID. Minecraft has said that this request ID has been processed, either unsuccessfully, in which case we'll print it, or successfully, in which case we won't do anything. Now, when we send it as we send commands, let's not actually directly send them. We'll put them instead into the sent queue. How exactly do we do that? What we'll do is modify our function where we're sending it. Yeah. In send, we won't actually send it. We'll just append it to the queue. That we can do by saying send queue dot push and just push the message instead of the entire the JSON stringified one. Now, once we process the command responses, what we'll do is send whatever pending commands. So let's say we first figure out how many commands we can send. The count of commands we can send can be, let's see, 100 minus the size of the awaited queue, which is basically object.keys of awaited queue dot length. And of course, this what if the awaited queue has, no, actually, yeah, this is the number of commands we can send. But let's also look at the number of commands we need to send. That's the send queue size. So take the minimum of those, math.min of send queue command.length. So this is how many we want to send, and this is how many we can send. The minimum of the two is the count. What we'll do then is for counter is 0, go until the count and send that many commands. The command is basically send queue's first item. Let's get that using shift. So that's removed it from send queue. We'll send into the socket the stringified version of the command, but technically this is a message, so we'll use message. Are we using, oh, we're also already using constant called message. Let's say, okay, command, it's fine. We'll go with command. And then we'll also say that now that we have sent it, the awaited queue should await this response. Awaited queue of command.header.request ID is command. So we index it based on the request ID so that when we have received the response, we can clear it from there. And that's about it. So once we've sent all the commands that we can, we wait for the next message and clear it. Let's run this now. And let's move up a bit and create a new, escape the pyramid. Let's go higher up and somewhere else. Now let's create a pyramid here. We'll connect to our WebSocket and we'll create a pyramid of size 10. And that is creating a larger pyramid, even though we are, oh, okay, we still are doing console.log. That's odd. Why is it? Oh, okay. It's printing the status code message. Let's print a message and see what this printed. And just for validation, let me move to a different spot and create the pyramid here. So we'll restart the server, reconnect, and pyramid 10. Okay, that's created the pyramid, and it's printed a few statements saying the block couldn't be placed. Now, the reason is my rectangle algorithm isn't perfect. What I'm doing is, supposing I want to place x, 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 and then an x, 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 and so on. I'm not actually, what I'm doing is saying place the top row first and the bottom row first. And then I'm also saying place this left row and place this right row, because I'm not saying place anything in the center. So that part vanishes. But because I'm saying place this twice, both as part of the row as well as part of the column, Minecraft saying I can't place that close to one because it's already there. So that's what's leading to these messages, and it'll be literally one for each corner. So there should be roughly 40 or well, close to 40. For the top, there may be a bit more or less. How many messages do we have? Yeah, we have around 40 odd messages. So this is simply because of the way I've structured the pyramid algorithm. But what this means is that now we can pretty much get Minecraft to take any request from a player, do anything on the player's behalf, and well, create more interesting worlds.